Good day, viewers at home. You are welcome to Mathematics Lab with Mr. Major. If you are just coming across this video on properties of angles, there is a part 1 of it in this channel. So you can check the channel for the part 1 of properties of angles. There you will see the work on vertically opposite angles, sum of angles on a straight line, and sum of angles meeting at a point. Now, in this part 2 of properties of angles, we'll be looking at corresponding angles, alternate angles, and interior angles on the same side of a transversal. Now, let's start with theorem number 4, which states that corresponding angles are equal. What are corresponding angles? I will put it in a way that we can easily understand it. When two angles are occupying the same position, then we say they are corresponding. Now, in this figure we have here, this line is parallel to this line. And then this other line that is cutting across the parallel lines is what we call a transversal. It is a transversal. So when a transversal cuts across two or more parallel lines, we have corresponding angles. Now, these are corresponding angles. If we look at this B, permit me to use the terms I'm about using now for better understanding. This angle B is occupying the top side of this line, the top side of this parallel line, and at the right hand side. So let me say top right hand is occupying the top right hand of this parallel line. Now when we come here, this F is equally occupying the top right side of this parallel line. So this is top right side, top right side. Both of them are occupying exactly the same positions of the two parallel lines. So we say angle B is corresponding to angle F. Therefore, they are equal. Now, let's look at angle C. Angle C is occupying the bottom right side of this parallel line. Angle G here is equally occupying the bottom right side. Exactly the same positions. So we say angle C is corresponding to angle G. Therefore, they are equal. Let's come here. Angle A is occupying the top left side. And angle E is also occupying the top left side. So that means angle A is corresponding to angle E. Therefore, they are equal. On the same vein, the angle D here is occupying the bottom left side, and angle H is also occupying bottom left side. The same positions. Therefore, angle E is equal to angle H. And the reason for each of these cases is that they are corresponding angles. So this is what we mean by corresponding angles. Let me come over here. We use the same rule to determine the corresponding angles here. This line is parallel to this line. So this one is the transversal cutting across the parallel lines. Now, angle W is at the top left. Angle M is also at the top left of the two parallel lines. So we say angle W is equal to angle M. The same thing, X is at the top right, N is at the top right. So that means X is equal to N. Now, angle Z is at the bottom left. Angle Q is also at the bottom left. That means angle Z is equal to angle Q. And the same way, angle Y is at the bottom right, and angle P is also at the bottom right. That means Y is equal to angle P. And again, the reason for each of them is that they are corresponding angles, and corresponding angles are always equal. Please let me reestablish that corresponding angles can only be possible or obtained where we have parallel lines with a transversal cutting across the parallel lines. So that is for corresponding angles. I'm going to use these same figures to explain the next theorem, which is theorem number 5, that says alternate angles are equal. Now, two angles are said to be alternate. Number one, for two angles to be alternate, they must both be at the interior side of the parallel lines. What that means is that in this first figure, we can only obtain alternate angles from D, C, E, and F because they are all interiors. They are all enclosed in the parallel lines. Now, which of them are alternate here? The ones occupying the reverse positions. When I mean reverse positions, the angle D here is at the left hand side of this parallel line, while angle F here is at the right hand side of this parallel line. That means it is left and right. I call them left and right. So left, right of the two parallel lines, not of the same parallel line. D and C is left, right, but they are on the same parallel line, so you can't call them alternate. It has to be one in this parallel line, one in this parallel line. So left, right. That means angle D is alternate to angle F. The same thing, left, right. E and C, left, right. So angle E is alternate to angle C. And alternate angles are also equal. Alternate angles are equal. So these two angles are equal, these two angles are equal. Let's bring it here. If we look at this one, we have the two parallel lines here, and the ones enclosed inside are X, Y, M, Q. Now, like I said, for two angles to be parallel, they must be at the reverse side of the transversal. Now, in this transversal, now if we look at these two angles, they are at the opposite sides. This one is, let me say, up, down, up, down. So that means angle X is alternate to angle Q. Therefore, they are equal. The same thing here, angle M and Y. Let me say up, down, up, down. So M is equal to angle Y. And the reason in each of these two cases is that they are alternate angles. So therefore, they are equal. So alternate angles are equal. Corresponding angles are also equal. Now, the last theorem on the board is the theorem of the interior angles on the same side of a transversal. And the theorem says that they are supplementary. Angles are said to be supplementary when they add up to 180 degrees. What that means is, since it is interior angles on the same side of a transversal, this is the transversal, and the interior angles are D, C, E, and F again, like in the case of alternate angles. Now, the ones occupying the same side, that is maybe the left-hand side, will be D and E. So we are saying that D added to E will give us 180 degrees. The same thing in the interior angles here, C and F are at the right-hand side. So C plus F are also supplementary. That means they add up to 180 degrees. So these are interior angles of a transversal. The same thing is applicable here. X, Y, M, and Q are the interior angles of the transversal. Now, X and M are at the same side. Let me say at the top side of the transversal. So that means X plus M is 180. degree. Then y and q are at the bottom side of the transversal. So we say y plus q equal to 180 degree. The reason is because interior angles on the same side of a supplementary of a transversal are supplementary. Okay, so now in the next video, please click the link in the description of this video to take you to worked examples on properties of angles. Thank you.